to digital image basics. So before we get into creating our own projects and getting into learning all these new skill sets and watching tutorials and everything, we've got to understand the vocabulary and the language that's used in this digital realm. So that's my goal with this presentation, is to introduce you to this basic vocabulary, terms that are going to come up throughout the semester, and if you're going into this realm as a career, that are just going to be part of your everyday professional language. Okay? So a digital image, if we're thinking of an image itself, an image is a representation of a scene on a two-dimensional surface. This stretches back all the way to like painting, historical painting, the kind of question and issue that artists, painters have been dealing with since the sort of birth of an artistic medium is how do you represent a three-dimensional world on a two-dimensional surface. So we're dealing with imagery in this class in terms of digital image is a numeric representation of a two-dimensional surface. So we are dealing with zeros and ones. Any digital image that we see on a screen is actually just a translation of those zeros and ones. So the first digital image, and I give you these questions to kind of think about, like, when do you think the first digital image came about, especially in thinking in terms of the pace of our technology right now? Like, how long ago do you think a digital imagery was born? Well, this is the first digital image of a baby from 1957, and I have a link to an article that I'll share who talks about the inventor of the square pixel, which I'll get into the pixel in the next slide, and how this was the very first image that was scanned into a computer, which is kind of fascinating. And we're thinking this time too, in 1957, the size of a computer is about the size of my living room. So a pixel stands for picture element. Every digital image consists of this little square particle called a pixel. You are probably already familiar with this term. You're probably familiar with when someone says, "Oh, that image is so pixelated," and that has to do with also the quality and density of the image. So a megapixel is 1 million pixels, and that resolution is the density of pixels, which I'll talk about in a later slide. So you can see in this image of the peacock that if we are zooming in to the beak, that beak is actually made up of singular squares of units of color that make up the representation of that beak. So a bit is each pixel contains a series of binary numbers, zeros or ones, as I mentioned, and the accuracy of each pixel in presenting a color it is called a bit. It's another unit of measurement which comes from binary digit. The capacity of each pixel, called bit depth, is the defining number of bits that a pixel could have in it. So these smaller units that make up one individual pixel. So in this next slide, you'll see that when a pixel has more bit depth, it means that it can present more colors and more unique shades. And I have another illustration in this that'll further describe that phenomenon. But if you look, so an 8-bit image has 256 colors. That's really not that many colors compared to what our eyes can see if you're a non-colorblind person, and the capacity of the number of colors that can be recorded by our smartphone cameras. But this just shows you that as the bit depth increases, so too does the representation of colors and shades. And most of our digital images have 0 to 16 bits per pixel. So they can use a total of 8 zeros and ones in an 8-bit pixel, for example. okay? And we're not going to get too nitty-gritty into bit depth and bits and sort of calculating the number of bits within each pixel and within digital images, but these are terms that you should know about. So in this illustration, you can see that 1-bit representation of an eye. There are only 2 possible values, the sort of gray and the white, the darkest dark and the lightest light. In the 2-bit imagery, then you times that by 2, you have 4 possible values. So you get a little bit more definition. And then jumping to the 8-bit, where you have 256 possible values or colors, it starts becoming more photorealistic. So this is just to give you an example of, an 8-bit pixel image, this sort of like iconic Mario Brothers, Super Mario Brothers imagery. And you can also make your own 8-bit art. There are a lot of websites where you can do that if that's your aesthetic. So vector art versus raster art, this is huge for us, and this is a concept that we're going to address throughout the semester, and it's really important to develop a firm understanding to be able to distinguish between these two terms, as this really, if you're going into a digital art or design realm, this is a foundational element that you must know, basically to save yourself humiliation in the professional realm moving forward. So raster art includes digital photographs and graphics created in Photoshop, for example. Raster art uses pixels, okay? Vector art does not use pixels, but rather uses math. So zeros and ones, points, lines, shapes, using math to create art. Vector art is only created in vector editing software like Adobe Illustrator. Vector graphics can be scaled indefinitely without using any image quality. So that's why we want to create logos, illustrations. We want to create those in Illustrator so that we can print our illustration on a postage stamp, which is very small, and use that same illustration on a billboard without sacrificing image quality. Why should I care about this difference? So like I mentioned, if you're creating a logo or something or an illustration in Illustrator, you can drastically change the size without distorting the image. And if you look at this example of the bottle, you can see the sort of difference between vector image quality and raster or bitmap image quality. You might hear me say bitmap to reference raster graphics too. Here's another example of vector versus pixel, or pixel equals raster or bitmap. So drawing a simple sphere in Illustrator, I can make that sphere as big or as small as I need to. But if I am creating that in Photoshop, which uses pixels, I'm going to be severely limited just because I'm using pixels. Okay? And I almost wanted to name this class raster versus vector, but I didn't think anyone would sign up because you just don't know what that means yet. But this is a foundational concept to our class and to our work this semester. So digital image file types, we're going to come up against this later in the semester, especially when we get to editing digital photographs. So you're going to hear these two terms, lossy and lossless. And you're also going to hear this term compressed. So compressed is what it sounds like when something is squished. It's made smaller. And that compression can be categorized as lossy or lossless. So lossless compression means that all of our image's information is preserved. It's saved. Our image size is going to be larger, but because it's larger, we maintain higher image quality. By By contrast, lossy compression creates a smaller file size, but discards a bunch of the data's image, or a bunch of the image's data. So we might lose some dimension, we might lose some value, we might lose some color because our file is smaller. So these are also some common file types that we'll encounter throughout the semester, the first being a JPEG. So a JPEG, or Joint Photographic Expert Group, this is a compressed file, and that compressing of the image maintains the brightness, but can also discard colors and sort of like adjust the vibrancy and the contrast through that compression process. And you can see in this example where the uncompressed file is much sharper, there's more detail, there are more colors, and then the JPEG compression, we can kind of see the pixels and this sort of square format. We've lost a lot of detail. JPEG format supports only 8-bit images. Okay, so it's just something to think about in terms of when you are working in Photoshop, for example, and you are utilizing a format called a Photoshop document, which is the second term on this list. This is a layered image file, which will make more sense once we start working with the program, but it's a larger size document, but it maintains all of our images information, and that's what we want. So we don't want to compress all of our images straight to JPEGs because we'll lose a bunch of information that we just won't be able to get back. A PNG is a portable network graphic. This is also a raster graphic format that supports lossless data compression, and we will be using PNG files towards the latter part of the semester. You don't necessarily want to print PNGs. They're not great for printing, but they are great for screen-based work. An AI is any file created in Adobe Illustrator, which we'll get to fairly soon. An INDD is a document created in Adobe InDesign. PDF, which I'm sure you all are familiar with, is a portable document format. So presents a document independent of whatever software it was created in, like Word, for example. And a GIF, which stands for Graphics Interchange Format. We aren't using GIFs this semester, but might be something that I'm sure everyone has seen animated GIFs before or utilize Giphy or the Giphy keyboard. But now you know that that stands for Graphics Interchange Format. And GIFs are limited to only 256 colors. They're 8 bits per pixel. So we have a digital workflow, and we're working with 3 different kinds of devices. So a capturing device, such as a camera, you take a picture, and then you need to display that device or display that image on another device, such as a computer monitor. So maybe you sync up your camera roll via iCloud, or in our case, Google Photos or Google Drive, and then we can edit that photo on our display device. And then our printing device, which is connected to our display device, and we use that to control the output of whatever type of product or material we're looking for. Each of these devices has a different relationship with pixels and bit depth and different resolution types, which I'm going to talk about next. Okay, so here we go. So you can see the camera is going to utilize image pixels. The image is then rendered by the computer monitor in screen pixels, and then rendered again by a printer in ink dots. So a pixel, which we talked about earlier, if you go to print an image, we have to sort of specify the resolution or density of pixels for that printed work. So pixels per inch and dots per inch were introduced to relate the pixel to a real world visual resolution, such as a poster printed out. Okay, so pixels per inch stands for how many pixels an image contains per inch of distance. And this is also universal, and it doesn't vary from device to device, which is important to know. Dots per inch is used for printing. Most printers can create multiple dots on the paper to depict one pixel. And you can see in this illustration that when you're looking at the screen 72 ppi versus screen 300 ppi right below it, that the pixel density is much more when it's 300 pixels per inch versus 72 pixels per inch. And this is important for us to know about, because when we create printed work, we want to set up our document as being 300 pixels per inch. If we're doing screen-based work, we want to set up our document to have 72 pixels per inch as our resolution. Okay, so resolution, super important. The main numbers that we're dealing with are 72 for screen-based work and 300 for print-based work. So this makes a big difference and is important to know about, just in that if you go to print an image that has a low resolution like 72 and you enlarge that image in Photoshop to print to be poster sized, it's going to reduce the quality of the image and cause it to look pixelated. It's just not going to look good. So that's why it's so important to know the intention of the work that you're producing right at the onset of setting up the document, so that you don't lose valuable work and information later on. Okay? And these are the sources used in this presentation. Like I said, we're going to be covering all of these bases throughout the semester, and it's important to understand this basic vocabulary now, so that we can move forward in creating our own projects and applying these terms in an experiential way.